In this video, we're going to look at a few series, infinite series, and talk about their convergence or divergence. And I'm going to do this pretty briefly. And I'm going to talk about how I would look at these and maybe what test I would use, but I may not actually do the whole test just in the interest of time. You may have to look back and see how the tests were actually done. For this one, the first one, 3 to the n over 5 to the n plus 1. I guess for me, I look at 3 to the n and 5 to the n, and I think, well, that's really similar to this geometric series that converges. Okay? And the only thing I've done here is made the denominator smaller. Or I'm sorry, the denominator bigger, so I've made the fraction smaller. So this is actually less than the geometric series because I made the denominator even bigger. So I would just think by direct comparison, we could say it converges. Okay, I would directly compare it to the geometric series. Now the next one, n to the 10th over 10 to the n, for that one I might think about maybe ratio test. And I might say, well, if I went to the next term, and the reason I'm picking ratio test is I like to do that when I'm mixing things that are exponential with things that aren't. Yeah, I think that works pretty well. So ratio test says if I take the next term and divide it by the current term and find the limit, I'll know if it converges or not. Well, I take the limit as n goes to infinity. Dividing by a fraction is the same as multiplying by the reciprocal. So let me do that. I can get rid of that. I could do a little bit of algebra here. I could say 10 to the n over 10 to the n plus 1 is just 10. And therefore I've got a limit as n approaches infinity. I've got 10n to the 10th on the bottom, and I've got n plus 1 to the 10th on the top. Now, if I expanded out the top, imagine I actually expanded it out. The very first term would be n to the 10th. I'm just going to put a little, it'd be n to the 10th plus blah, 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 blah. I would go on and on and on. So I'd have n to the 10th as my high power. So n to the 10th over 10n to the 10th is 1/10. Now, because that's less than 1, by ratio test, this converges. Remember, you need the ratio to come out to be less than 1 in order to converge. Okay? The next one, n squared minus 1 over 2 to the n. We might be able to use ratio test on this one as well. We could certainly try it. We'd have n plus 1 squared minus 1 over 2 to the n plus 1. In the interest of space, imagine, okay, I'm dividing by the term, but I'm multiplying them by the reciprocal. So let me do that. Take the limit as n approaches infinity. Do my algebra. That. So on top, I've got n plus 1 squared minus 1. And on the bottom, I've got 2n squared minus 2. Taking the limit as n goes to infinity. And similar to the last one, if I expanded the top out, I'd have n squared plus 2n plus 1 minus 1. So I'd have n squared over 2n squared, which is a limit of 1/2. And again, by ratio test, if you get something less than 1, it converges. Let's look at a few more. N squared times e to the negative n. Okay, I don't like to deal with these negative exponents, so I would maybe start by just rewriting this as n squared over e to the n. And again, I like to use ratio tests when I have a mix of power and exponential, or exponential and factorial. So I would probably go again to the ratio test. And again, instead of dividing by the thing, I'm going to multiply by the reciprocal right away. And we take the limit as n approaches infinity. Do your algebra, and I think you see that it's going to be n plus 1 squared over en squared. The limit's going to be 1 over e, which is less than 1. So by ratio test, it converges. Remember, ratio tests, we're looking for less than 1. Okay. Again, I think another time to use ratio tests because of the factorial and the exponential piece. So n plus 1 factorial divided by e to the n plus 1 multiplied by the reciprocal. Limit as n approaches infinity. That cancels with that. Now, n plus 1 factorial divided by n factorial is just n plus 1 on the top. So we end up with n plus 1 over e. Well, the high power's on the top, so the limit's infinity. So by ratio test, this diverges. Okay. Now, this last one, I would look at this and I'd say, well, n multiplied by n to the 1/2 is the same as 1 over n to the 3/2. And because the power is greater than 1, this is a p-series that converges. Okay. Remember, if that power is greater than 1, if it's 1 over n to a power and the power is greater than 1, it automatically is a convergent p-series. In this problem, we got a lot of mix of things happening, you can see, but again, I like to use ratio tests when I have a mix of geometric and, exponential and power things, or exponential and factorial things. Ratio test, I think, is one of my favorite tests. So I'm going to do the next term. And dividing by the current term, same as multiplying by the reciprocal. Remember, we're taking the limit as n approaches infinity. So let's do some algebra here. So I've got a 3n cubed on the top. And I've got a 2 times n plus 1 cubed on the bottom. Limit as n approaches infinity. Now, if I expanded the bottom out, right, if I expanded this out, I would have a 2 times n cubed. And there would be other terms. So the high power would be n cubed. So I've got 3n cubed over 2n cubed. The limit is 3/2. So this diverges by the ratio test. Because remember, that ratio, once we do it, that limit has to be less than 1 to get convergence.